So here we are with the 1-4 multi-step equations notes, and we are actually doing multi-step rather than the last day, which we did two-step. So this is your day 2 notes. So we're going to solve equations in one variable that contain they're going to complain more than one operation. Super. So taking a look, what happens is equations that are more complicated may have to be what we call simplified, or a lot of times it's actually more like combining like terms. So they need to be simplified before they can be solved. You may have to use the distributive property or combining like terms. So again, this is the idea that we're going to do today, and then our last set of notes was that distributive property. So we saw a set of parentheses and had to distribute first. So we're going to do the combining of like terms before we begin using inverse operations. So for instance, what's going to happen is there's going to be like a 2x plus 5 plus 3x. Okay, and the idea is that instead of, and then it'll equal whatever's over here, instead of just subtracting a 2x over to the other side, we're going to think of this as its own unit first. And we're just going to combine the 2x and the 3x and actually have this left side say 5x plus 5. Now the biggest problem that happens here is that because you are thinking of doing opposite operations, you will try to subtract 2 over to this 3x. But the only time that you do opposite operations is when you're going across the equal sign. And we're not going across the equal sign. So really you're just taking or combining those two x's. If you want to think of it, because order doesn't matter with addition, you can go ahead and move this one over here. If you move it over there, you're actually visualizing that it's 2x plus 3x right next to each other plus 5. And therefore, you wouldn't ever subtract when you're going to do it that way. All right. So let's go ahead and move on to our examples. So here's our first example, and hopefully if you draw the line at the equals sign here, you can see that on the left side there's an 8x and a 5x. Double check that the 5 is actually a positive right over here, and then 8 is a positive as well out front. And so we're going to put those two pieces together. Again, a little easier to look at is if I just take the time to rewrite 8x and 5x next to each other, then the negative 21, or the subtracting of 21, and the fact that it equals negative 15. So if you take the time to rewrite it, you'll notice that 8x and 5x will not have opposite operations right now. They're just going to combine together to make 13x's, and then we'll still have minus 21, and the fact that that equals negative 15. All right, then to both sides, I'm going to add 21. So now we're going into opposite operations because I'm going across that yellow line there. And we'll be left with 13x, and that will equal negative 15 plus 21, which is a disgusting 6. Okay, why is it disgusting? Because now if I divide by 13, I'm going to get the terrible decimal of 6/13. All right, and so we can then say that our x value is going to be 6/13, or if that feels incomplete to you, you can also get your decimal. I just don't usually get the decimal unless it's what we call a terminating decimal, which means that you can find that repetitive pattern or it actually stops. And in this case, it doesn't, and so this is actually where technically you would be doing those kind of like about symbols, okay, because it's about 0.46, but it does of course keep on going, and so that's kind of the reason for those little about symbols. So again, I usually just keep it as a fraction, even though that feels unfinished. That is actually the official answer. All right. All right, then we move on to the next one, and oh my gosh, instead of just having combining like terms, they also have distribution in this one. Okay, so first thing that we're going to do is try to combine like terms, but notice that this 4y is inside of those parentheses, so we can't really do that. So instead, we're going to distribute this negative 1. If you want to think of it as multiplying by negative 1, that's cool, or you can just think of it as distributing the negative. So everything is going to be the opposite sign of what it is. So since this is a positive 4y and a positive 8, they'll both become negative. So officially we'll have 10y, and then to that we're going to subtract 4y and subtract 8. Then again on this yellow, or on the left side here of the yellow line, we can combine together our 10y and our 4y. Again, you're going to wonder why we're subtracting, but it's just whatever symbol is there, we are not doing the opposite of it, because again, we're still on that same side. So 10y minus 4y is going to make 6y, and we still have subtract 8, and still have negative 20. Then we're going to add 8 to both sides. As we think of the order of operations of SADMEP, the subtraction and addition would come first. So we're adding 8 to both sides, and now we'll have negative 12, which works out nicely because we have 6y, which means we will divide both sides by 6. And so as we're on our division and multiplication, we end up with a y of negative 2, and there it is. Now technically you can plug that back in and check it, but as we're going through multi-steps now, as long as we had that one-step practice, we should be able to get to that result without having to double check. But of course you can make sure that you have all of the right answers by double checking. Alrighty. So that was our day 2 of these notes. So hopefully, whoops, wow, I just keep drawing lines. Hopefully you understand more about, in this case, solving multi-step equations. You always want to look for distribution. Just call it distribution, distrib. And then after distribution, you're always looking for combining like terms. And then after you combine like terms, then you're starting to do SADMEP. Wow, this pen's working well today. All right.